look with our eyes at what we've got, assessing a couple of things and determining how we can describe our function. So there's 4 main descriptors, and these should all sound familiar because we've talked about all 4 of these terms before. The first term is this. What does that say?
Linear.
Linear. What does linear mean?
Like line.
A straight line, right? So we know we have a linear function if the graph is a straight line.
Going through.
Don't say that just yet. Just a straight line. If the line is straight, it's linear. If we're looking at an equation, right, you could look at a graph or you could look at an equation. The graph is nice and easy to tell. It's just going to be a straight line. We know that an equation is linear if it does not have exponents in it. You guys know what an exponent is? We just did volume. You definitely know what an exponent is. It's the little number up on the top. Okay?
It's right there on the bottom.
Down here, yeah. So some examples of linear functions would be y equals 2x plus 1, y equals negative 3x, and y equals x. These should all look very familiar. This is when we were graphing our lines, right? Y equals mx plus b, oh mama's ex-boyfriend, all that good stuff. Those are all linear functions, right? When we plotted the points, rise and run and all that good stuff, we ended up with a nice straight line. Right? Give me a thumbs up if that all makes sense. You remember all that. Good. So the opposite of linear would be what? What does it say right there? Non-linear. That means that the graph is not a straight line. Yeah, it's something that's not just a straight line. It's easy to tell if you see a graph. Is the line a straight line? No. Well, then it's non-linear. But if I have an equation, what I'm looking for is exponents. A nonlinear function's equation has exponents in it. Like we said, exponents are those little tiny numbers up on top of the x, like 3x squared minus 4, y equals x cubed, or y equals 1/2 x squared. Actually, since we have a little bit of space for linear functions, let's draw a nice little straight line here. And then for nonlinear functions, we're going to draw like a little U-shaped line that looks like that. Those are my first 2 big indicators that we're going to use to describe some functions. Is it linear? Is it nonlinear?
Linear.
Every function we look at is going to be one of the 2. You get a 50-50 shot figuring out which one it is. Does that sound good with nonlinear functions? Give me a thumbs up. That sounds good. Perfect. Next, what does this word say? What does this word say? Proportional. Have you guys heard proportional before? Oh, absolutely. Didn't we start out with that? Yeah, August. Graphs of proportional relationships. Do you guys remember what makes a relationship proportional? What about it? If I'm looking at a graph, how do I know it's proportional?
It has a variable.
It does have a variable. It has 2 variables. Zach, what did you say?
Goes through the origin.
It goes through the origin.
Oranges.
What are the coordinates for my origin?
0, 0.
0, 0. Now, proportional functions are a little more complicated, right? We're not just looking for one set of criteria, we're looking for 2. So not only does it have to go through the origin, but it also has to be a straight line. What do we call graphs that are straight lines again? What is it? A straight line? Linear, yeah, linear. Okay, and this is where we typically get confused. Proportional, linear, these things kind of blend together. Linear, you should see line. It refers to the shape of the actual graph. Proportional tells me where does that graph cross the y-axis. If it crosses at the origin, it's proportional, as long as it is also a straight line. And of course, this equation does not have a b value, also known as a y-intercept. So if I think back to y equals mx plus b, I shouldn't have any plus or minus b on the end of my equation. I should just see y equals mx, y equals mx, y equals mx. Just like that. All right, there's no b over here, no b on the end, no b. So if I'm looking at a graph, I need to see, is it a straight line? Does it go through the origin? But if I'm looking at an equation, I say, okay, there's got to be no exponents for it to be linear, and there's got to be no b value for it to be proportional. Is that all making sense so far?
Yeah.
Okay, we got one more. Obviously, the opposite of proportional would be what?
Non-pro.
Non-proportional. So non-proportional, these graphs could be linear or they could be non-linear. And this is where people really get confused. Non-proportional just means it does not go through the origin. Whether it's a straight line or a U-shaped line, if it does not go through the origin, it is not proportional. So we'll see these equations do have a b value or an exponent. So y equals 2x plus 3. That plus 3, that's my b value. I know right away that's non-proportional. Y equals x squared. I see that little exponent. I know right away that it's non-proportional. Even though it doesn't have a b value, for something to be proportional, it has to be a straight line. And if it has an exponent, it's not a straight line. Okay? And y equals x minus 1. Boom, there's my b value right there. So I know that that is non-proportional as well. 4 different ways to describe a function. Every function we look at is going to have 2 descriptors, either linear or nonlinear, and proportional or non-proportional. How's that sound? Quick show of thumbs. Up, down, sideways. I'm trying to make this efficient. Ooh, a lot of sideways. A couple thumbs up. A couple no thumbs. Okay. Once we actually see some examples, hopefully it'll make some sense. Here's some examples. Once you get this second page, go ahead and glue it in real quick. We'll jump right in. Sure. right, give me a thumbs up. You got this glued in? Okay, here we go. So we're going to start with figuring out whether it's linear or nonlinear, because especially when I have a graph, that's a lot easier for me to do. Is this first graph here a straight line?
Yes.
Yes, it is. So is it linear or nonlinear?
Linear.
Linear. There's one. Now we have to determine if it is proportional or non-proportional. Remember, linear functions can either go through the origin or not. Does this line go through the origin? Yes. So is it proportional or non-proportional? Proportional.
Yeah.
Right? There's my two descriptors right there. Linear and proportional. Everybody with me on that? Cool. Second one right here. Is that a straight line? Yes, it is. So is it linear or nonlinear? Okay. Now remember, linear functions can either go through the origin or not. Does this line go through the origin? No. So that is non-proportional. That's right. Now those ones are nice and simple. We've seen those all before. What's that? Okay. Yep. This third one here. Is that a straight line? No. So is it linear or nonlinear? Nonlinear. See, I told you this would be easy once you actually see it.
It is proportional.
It is proportional, you guys say? Why do you say it is proportional? Ah, good. Let's take a look back at what it means for something to be proportional. It's got to go through the origin, and it's got to be what?
Proportional. Does not have a b value.
Okay, look above.
Go 0, 0, go to the origin.
It's got to go through the origin, and it's got to be a straight line. So this goes through the origin,
But it's not.
but it's not a straight line. So it's non-proportional.
Told you guys.
Yeah, right, go ahead. So with this work, right, there's 4 options for descriptors. The only pairing we cannot have is nonlinear proportional. That'd be like saying you're short and you're tall. You got to be one, right? Nonlinear proportional is not going to exist because for something to be proportional, it has to be linear. So as soon as you see one of these curved lines, doesn't matter where it crosses the y-axis, it's nonlinear, non-proportional. Give me a thumbs up if that makes sense. Okay. This fourth one down here, what are my 2 descriptors? Who can give me one of my descriptors I can use?
Non-linear.
Okay, Rhea says nonlinear. Do you guys agree with that?
No.
Okay. What else can we say?
Not proportional.
Non-proportional, because if it's nonlinear, it's non-proportional. Great job. What about this 5th one, Alicio?
Oh, I have a question.
Sure.
If it's non-proportional, then is it also non-linear?
Not always. This one was non-proportional and linear,
Oh yeah.
right? It's like a circle, or not a circle. It's like a square and a rectangle, right? Every square is technically a rectangle, but not every rectangle is a square. You guys know that? Yeah.
Linear.
What about this one? Is that a straight line?
Yeah.
Yeah. So linear or not?
Yeah.
Linear. Okay.
Non-proportional.
Now, like you were saying, Alicio, does this one go through the origin? Nope. So Diego, what is it?
Non-proportional.
That's right. Don't say that. What about this last line here? Linear or not? Linear. And proportional or not? Proportional. Goes right through the origin.
Why would you say that?
Simple. When we have a graph, now we got to think a little bit harder with these equations here. The first thing we want to look for is an exponent. An exponent tells me that it's non-linear. If there's no exponents, then it's linear. Y equals 3x plus 2. Do you see any exponents in there? No. So is this linear or non-linear? Linear. No exponents, it's linear. Now we've got to determine if it's proportional or not. What are we looking for to figure out if an equation is proportional or not? We're looking for a what?
No b value.
We're looking for no b value. Do you see a b value in 3x plus 2?
I do. So this non
Yeah, 2 is my b. So this is non-proportional.
How do you know if it's non-proportional?
We're looking for the b value. If you see a number on the end like that,
without
it's not proportional. Exactly.
So the next one's proportional.
Well, let's see.
because it has an exponent.
What do you see right there on that x?
Exponent.
An exponent. That little tiny number is an exponent. So I know it is non-linear, which means automatically, it doesn't matter if there's a b value or not, it's also what? Non-proportional. Okay? There's only 3 combinations we can have here. Linear proportional, linear non-proportional, or non-linear non-proportional. So every single one of these questions, you have a 33% chance of getting it right, even if you don't know anything about what you're doing.
When are we going to do the test?
Whoa, it's the second lesson. You always already want to know when the test is? 26th of February. You heard that right? You heard the date I said? Perfect. Third one, y equals 1/2 x. Do you see an exponent there? Nope. So linear or nonlinear? Linear. Do you see a b value on the end?
So you say that's 26?
That's right, proportional. That is what I said.
I heard you, but I didn't hear you.
Perfect. Last but not least, the third one. You see an exponent there? Do you guys see an exponent on that last one? I do. So it's nonlinear and non-proportional. That's right. Quick show of thumbs. How we doing on that? Thumbs up seems super easy. Definitely seems doable. Thumbs sideways seems a little bit tricky maybe. Okay. Perfect.